This is part 2 of note 7.4 about trapezoids and kites. So we're going to do 2 proof examples with trapezoids now. The first one will be a coordinate proof and the next one will be a 2-column proof. So take a moment to pause right now and write down the information for this proof. Okay, I want to prove that this quadrilateral is an isosceles trapezoid. So in order to do that, there are 2 steps. First, I have to prove that it's a trapezoid. The most straightforward way to do that is to do the slopes of all the sides and use that to show that exactly one pair of sides is parallel. Okay, the second thing I'll have to do after that is show that it's isosceles. I can do that with the distance formula. Either I can show that the diagonals are congruent, or I can show that the legs are congruent. That's my choice. So those are the 2 steps. And then at the end, be sure to state what you have proven. Okay. So I don't have to draw a picture of this, although I could if I wanted to. Just to get me oriented, I think I will go ahead. I have some negative points. So I have Q at -3, 2. I have R at -1, 6. 4, 5, 6. I have S at 4, 6. And then I have T at 6, 2. I'm going to use my straight edge to connect these points. Okay, looks like a trapezoid. I think I know which pair of angles should be parallel, which pair of sides should be parallel. Okay, so I'm going to do the slope formula. The slope for RS. I'm going to do the slope for QT. I'm going to do that one next since I want those 2 to be parallel. And then I'm going to do the slope for QR and the slope for ST. So for RS, I have change in y, so 6 minus 6 divided by -1 minus 4, which is 0. And then for QT, I have 2 minus 2 divided by -3 minus 6, which is 0. Okay, for QR, I've got 2 minus 6 divided by -3 minus 1, which gives me -4 over -4, which is 1. And then for this one, I have S is 6 minus 2 over 4 minus 6, which is 4 over -2, that's -2. So I've now shown that it's a trapezoid because one pair of opposite sides is parallel. So QRST is a trapezoid because exactly one pair of opposite sides RS is parallel to QT are parallel. So RS is parallel to QT. QR is not parallel to ST. All right, the next thing that I need to do is to show that my legs are congruent. So I'm going to find QR, and I'm going to find ST. You could also do the diagonals if you wanted to. So QR is the square root of -3 plus 1 squared plus 2 minus 6 squared. And that gives me the square root of 4 plus 16. So that's the square root of 20, which is 2 root 5. Over here for ST, I'm going to do the difference between my x's and then the difference between my y's. So S is going to be 4 minus 6 squared, and T is going to be, I'm sorry, this is ST, 4 minus 6 squared and then 6 minus 2 squared. And that is the square root of 4 plus 16, because this is 2 and this is 4. This was -2 and this was -4. And so that gives me square root of 20, 2 square root of 5. So QRST is isosceles because QR equals ST. Okay, so that's a coordinate proof for an isosceles trapezoid. Next, we're going to do a 2-column proof. We have to write this one down. So, given CDFG is an isosceles trapezoid with bases CD and GF. Prove that angle DGF equals angle CGF. Sorry, CFG. All right, so let's see, we need a figure for that. We have a base CD, and we have a base GF. All right, so let's see where these angles are. DGF, oh, we need some diagonals, don't we? Okay, now we have some diagonals. So DGF is congruent to CFG. So we need to prove some triangles congruent here. What I think I want to do is show that this and this are congruent. And then we have this shared side down here. And then we also know that diagonals are congruent. So this entire thing is congruent to that entire thing. All right, so we need to work out our triangles here. Okay, so 1 is going to be given. CDFG is an isosceles trapezoid with bases CD and GF. 2. CG is congruent to DF. That's definition of an isosceles trapezoid. 3. DG is congruent to CF. I have to do these two separately because this is not part of the definition. This is a theorem. This is a theorem that says that diagonals in an isosceles trapezoid are congruent. Okay, 4. All right, we've said those are congruent. Now we need to say that GF is congruent to GF. That's reflexive. VOC. And then we want to say that triangle DGF is congruent to triangle CGF, or sorry, CFG, and that's side, side, side congruency. And now, by CPCTC, I can say that angle DGF is congruent to angle CFG, and that is CPCTC. CPCTC. Okay, that's too many letters. There we go. All right, have a great rest of your weekend. See you on Monday.